Good afternoon, class. We are looking at Chapter 4, Applications of Derivatives, Section 4.1. Section 4.1, Maximum and Minimum Values. We have done a big chunk of the section, so we're going to move on looking at more examples. Find the absolute max, example 4. Find the absolute max and mean values of f on the given interval, where f of x is x over x squared plus 2, and the interval given is 0 to 4. So the first question is, what type of a function do we have here? This is a rational function. So what do we know about the rational function? A rational function is in the form of n of x over d of x. Needless to say, d of x can't be 0, the denominator. N stands for the numerator, d stands for the denominator. N and d are both polynomials. The domain of f consists of all real numbers except the zeros of the denominator of the function f of x. F of x. And so with that being the case, if you set this one equal to 0 and exclude that, that becomes the domain. When you set x squared plus 2 equal to 0, there is no solutions because x squared plus 2 is always positive. In fact, it is always larger than equal to 2. Although it's a rational number, the domain would be all real numbers. So f is a rational function. It's continuous from negative to positive infinity. Therefore, it makes it continuous in the given interval of 0 to 4. So now we are going to start with f prime of x. And to do f prime of x, we are going to use the quotient rule. So we are going to write f over g. The answer is f prime g minus g prime f over g squared. When I want to differentiate, I write the formula for me and I follow that. So f is x, the derivative of that is 1 times x squared plus 2, minus g prime, the derivative of the bottom is 2x times the top x. And I just write the bottom in a parentheses, that's g, and square that. And I'm done with differentiation. I'm going to simplify this. So I get x squared plus 2 minus 2x squared. These two add up, and it becomes minus x squared plus 2 over x squared plus 2 quantity squared. What happens next? F prime equals to 0. That means we are looking at this part. The numerator becomes 0, which means x squared becomes 2 and x is plus minus square root of 2. Now, f prime does not exist. The denominator is set to 0. And we said x squared plus 2 equals 0 has no solutions. When you square it, makes no difference. There is no solution. Therefore, we have two possibilities for the critical points, either square root of 2 or negative square root of 2 or both, and we have to see which one is in the given interval. As you can see, square root of 2 is in between because square root of 2 is 1.41 roughly, but minus square root of 2 is not there. So we can only use square root of 2. So we found the first part. Now the second part says find f of a, which is f of 0, f of b, which is f of 4, and f of all those critical points. There's only one critical point. Let's evaluate them by putting them into the original function. So let me clean up the mess. So this, and this, all of these three, we put it into the original function. We are going to put it into this original function. That's the meaning of f of 0. So 0 over 0 squared plus 2. It's 0 over 2. Makes it 0. Square root of 2 means square root of 2 over square root of 2 squared, which is 2, plus 2, which makes it 4, square root of 2 over 4. F of 4 is 4 over 4 squared, which is 16, plus 2, making it 18, and 4 over 18 is 2 over 9. So these are the answers, and clearly 0 is the smallest value, so absolute mean is equal to 0 at this pair, and this is larger than this. You may notice almost 4 times 2 is 9. So what about square root of 2 times 2? Because 2 is smaller than that, makes this one larger, but you can go with a decimal approximation to see that. So the maximum takes place at this pair, and it's equal to this value. So we're going to write absolute max square root of 2 over 4, roughly 0.35 at this pair, square root of 2 comma square root of 2 over 4, and absolute minimum is 0 at this pair. So I think it's pretty straightforward, everybody. Find the absolute max and minimum value of f on the given interval of f of x equals x to the power of 4 minus 18x squared. And the given interval is negative 4 to 1. First and foremost, recognize this again as a polynomial function. So I'm going to remind you what is a polynomial function. F of x equals a sub n x to the power of n plus a sub n minus 1 x to the power of n minus 1 all the way to a sub 0, where a sub n, all of those coefficients, okay, are important. A sub n, the first one can't be 0, and n, all of those exponents, they must be a whole number, where whole number is defined as 0, 1, 2 to infinity, and the domain is negative to positive infinity. Therefore, this is a polynomial of degree 4 with the same domain. It is continuous everywhere from negative to positive infinity. Therefore, it is continuous in the given interval of negative 4 to 1. So we can write f, or f of x, is a polynomial of degree 4, and it's continuous from negative to positive infinity. Therefore, it's continuous over the given interval of minus 4 to 1. So that's the first thing we need to establish. The second one is to go to f prime of x. To go to f prime of x, we are going to differentiate, and that's simple. How do you differentiate? 4x cubed minus 36x we're going to set it equal to 0 and solve. To do so, I'm going to factor out the 4x. I get 4x times x squared minus 9. X squared minus 9 can be factored into x plus 3, x minus 3. And therefore, if I set this equal to 0, I have 3 answers. X is 0, x is negative 3, x is positive 3. The next one is to look at f prime where it does not exist. F prime itself is a polynomial. It's a polynomial of degree 3. It exists everywhere. The domain is all real numbers. Therefore, f prime does not exist, does not produce any solutions. This is phi, a Greek letter representing an empty set. Therefore, those are possible critical points. Let's check with the given interval. Is 0 in between? Yes. Is -3 in between? Yes. Is +3 in between? No, +3 is larger than 1. So we can only use -3 and 0, which means we are going to go to this original function. We're going to evaluate it at these two endpoints and these two critical points. Perhaps if you write this as x squared times x squared minus 18, it's easier to evaluate. So now this is minus 4 squared, which is 16. Brackets, minus 4 squared, which is 16. Minus 18 makes it -2. And their product is -32. I'm telling you this because x to the power of 4, you may, -4 to the power of 4. -4 to the power of 4 is 256. I hope you know that. But in case you don't know it, this factoring makes it fast. -3 to the power of 4 is positive 81. But just in case, if we go with this one, we can write -3 squared, which is positive 9. -3 squared, which is positive 9. Minus 18, which is -9. And so 9 times -9 is minus 81. 0, I'm not going to evaluate it. Just plug in clearly. This one is easier. 0 makes it 0. 1 is very easy using this one. 1 to the power of 4 is 1. Minus 18 times 1 squared is 1. So that's minus 17. So these are the values. And therefore, all of them are negative except 0. Therefore, this is the absolute max at this pair. This is the absolute mean at this pair. So we write absolute max equals 0 at the pair of 0, 0, and absolute mean is equal to minus 81 at this pair. And we are done. Find the absolute max and minimum values of f on the given interval. F of t is given as t times 4 minus t squared to the power of 1/2, with the interval given as -1, 2. Again, pay attention to the fact that this is as it's supposed to be. It is a closed interval. Now, before I send you to a breakout room, I want to make a point of a couple of things. What is this f? F is the product of t and this piece. This piece, I'm going to write it as square root of 4 minus t squared. So t, which is a linear function, and square root of 4 minus t squared, which is a square root function. And as you recall, with any square root function, with any root function where the index is even, what's underneath must be positive. So 4 minus t squared must be greater than or equal to 0. So 4 minus t squared larger than or equal to 0. We are going to factor this to 2 minus t and 2 plus t. Setting each one equal to 0, this gives you 2, and this gives you -2. And now we use what's called a sign graph. Sine graph consists of a number line from negative to positive infinity. We put these two numbers in order, and the t, the variable of interest, may be t or x, going from negative to positive infinity, and the function of interest 4 minus t squared, it's 0 at negative 2, it's 0 at positive 2. And so we want to see what happens in between. So that's why this is called sine graph. So we use what's called TP, short for test points. The easiest would be in between, of course, would be 0. Here like -3. Here like +3. So if you put 0 into 4 minus t squared, gives you positive. If you put -3, this is 9. 4 minus 9 makes it negative. The same thing here, negative. So these are the signs. That's why this is called the sine graph. We go back to the question. We are interested in this positive. So we want this one, which goes from -2 to +2. Therefore, we say, according to what we found, f, which is a product of a linear function and a square root function, is continuous on the interval of -2 to 2. That's what we found. Therefore, it makes it continuous in the given interval of -1 to 2 because this contains the given interval. So the next step is to find CPs. Therefore, we need to find f prime, which is going to use the product rule. This is going to be f times g, and we are going to use this format, makes it easier. And as you know, the product is f prime g plus g prime. So I would write the formula and use it. So f prime makes it 1 times the second piece, just the way it appears. And you can use this one or this one. Ultimately, we're going to change it to this one, this format, plus g prime. The derivative of the second piece uses the extended power rule, 1/2 times 4 minus t squared to the power of 1/2 minus 1, which makes it -1/2. By the chain rule, the derivative of the inside, or minus 2t. So again, 1/2, 4 minus t squared to the power of -1/2. The derivative of the inside is minus 2t. And now we need f t. So I'm going to write f prime g plus g prime f. Becomes clear as to what we have. This one, of course, we change it to this format. This one, the same format in the denominator. Notice 1/2 and -2t squared, their product is -t squared. So again, 1/2 goes away. This becomes -1. -1 times t is -t squared. So again, we are going to go with the algebraic steps now. It's very simple. There is really not much to it. I just want to make sure that we get this. It's extremely simple, everybody. So what happens now? This one is this. This goes down, and then +1/2, -2t, and t gives us -t squared. We are going to take a common denominator because of the next step. We are going to take a common denominator of square root of 4 minus t squared. So this remains. What happens to this one? Please understand now, this one, we are going to have the denominator 4 minus t squared under the radical. That means we need to multiply these two and put it at top. We get 4 minus t squared. Now, if you add this numerator to this numerator, you get 4 minus t squared minus t squared, making it 4 minus 2t squared. And the denominator doesn't change, square root of 4 minus t squared. So I hope it's clear to everybody as to what's going on. Okay. Let's continue. So we have this f prime of t, and as you recall, a fractional format is 0 when the top is 0. We need to go to f prime equal to 0. So set the top equal to 0, 4 minus 2t squared is 0. This means 2t squared is 4, t squared is 2, and t is plus minus square root of 2. We are doing elementary algebra. Now f prime does not exist. A fractional format does not exist, or it's undefined when the denominator is 0. And the square root of 4 minus t squared is 0 if inside the radical 4 minus t squared is 0, which makes t squared equals 4, t is plus minus 2. So there are 4 possibilities for critical points: positive, negative, square root of 2, positive, negative, square root of positive, negative 2, and we are going to check all those 4 numbers with the given interval. And bear in mind, square root of 2 is about roughly 1.41. So is square root of 2 in between? Yes. Is negative square root of 2 in between? No, because it's negative 1.41. It's to the left of negative 1. Positive 2 is one of the endpoints. That works. Negative 2 does not work. So we have only 2 and square root of 2 to work with. So all we have to do, go back to the original function, either in this format or in this format, plug in these 2 pairs, okay, these 2 points, plug in negative 1, f of a, plug in 2, f of b, and plug in these 2. Well, 2 is taken care of, plug in also square root of 2, and evaluate them. We are going to use the original function, which means if I want to go with negative 1, I am going to write again, we are using the original function. I'm going to write minus 1 square root of 4 minus negative 1 squared, which is positive 1. 4 minus that is square root of 3 times negative 1. I hope you see that this is minus square root of 3. If I put square root of 2, I get square root of 2 times square root of 4 minus square root of 2 squared, and I hope you see it's the product of square root of 2 and square root of 2, which is 2. If I plug in 2, I get 2 square root of 4 minus 2 squared, which is 0. So their product is 0. So those are the answers. And this is the only negative number that is the absolute minimum. And this is the largest value is absolute maximum. So absolute maximum equals 2 at the pair square root of 2, 2. And absolute minimum is minus square root of 3 at the pair negative 1, negative square root of 3.